Hi, my name is George Semaganda, and thanks for subscribing and kindly subscribe if you haven't subscribed to my YouTube channel. Today, I'm going to do a presentation about a machine learning review paper. Our project is modeling for climatic geointelligence to predict food security. My name is Semaganda George. My students' details are in here. So I'm doing a review for a machine learning paper. The machine learning paper is called is an adaptive bias correction for improved seasonal forecasting, and that's a paper with these are the authors of the paper. It was received on in 2022 September. Uh, of 23rd of September. Briefly, let's dive into the introduction. So the introduction, why about of why the gentleman came up with this paper is the predicting precipitation weeks in advance presents a significant computation challenge. So this presents a significant. This presentation explores a novel forecasting system that utilizes machine learning and advanced statistical techniques to tackle this problem and improve the accuracy of week 3 to 4 US precipitation forecasts. So if we continue, we shall dive into the computation problem. The computation problem is basically I saw it's subdivided into three. One is the atmospheric dynamics, then chaotic systems, and data intensive modeling. So if I continue of why we need a machine learning approach to this, the gentleman came up with a model they called the ABC Assemble. The assemble basically means we bring more than one model together to attain our goal, what we want to use it to analyze the data to attain the required goal. So the presentation focuses on machine learning system featuring the ABC, that is adaptive bias correction ensemble, at the heart of the computation approach for generating the forecast. So when applied to the sub-seasonal model from the European Center of Medium Range Weather Forecasts. So briefly, this is model construction on how the model is constructed. So we see our ABC model here. It receives data, all observations from historical observations. That is the ECMF WF, then the climatology plus plus, that is one of the models used, then persistence plus plus, and then the ECMWF plus plus. So all if they combine these all together, then they get an ABC ACMFC model. That's what they called it. So they try to minimize the biases around this the model, and at one point they use the Court-Shapley. Court-Shapley basically helps to understand the different variables used in a given model and how they are helping us to achieve the required goal or the result. So this is a breakdown of the model, that is the ABSC assemble. So the ABS assemble combines the strengths of three distinct models, that is dynamical, climatology, and the persistence for this kind of problem. So if we continue, we are going to dive into the details of these different models. For dynamical plus plus, what is it? So dynamical is physics based and it utilizes dynamic models, complex computing simulations that solve the physical equations governing atmospheric behavior. So give an example of the Navier-Stokes equation. This uses partial differentiation. Then it employs, still the dynamical employs a core component like the European Center of Model, which is a leading global atmospheric model. So it requires significant computation power to simulate the atmospheric process and generate forecast. So if you use the dynamical, this is a visualization of what they came up with, a skill against the precipitation weeks. So we have between 3 to 4 and then 5 to 6 weeks. So you see skill is plotted against the different models of how different models are performing, tested. So this is our ECM WF, and within the fifth week, this is the value they have, the fifth to sixth week. So the climatology model, it's statistical and analyzes historical weather data between the past weather patterns and then the future precipitation events. So it uses the historical weather data to predict the future weather. So probably, basically, climatology uses an algorithm like linear regression and random forest for its operation. So if we continue further, we can look at persistence. What is with persistence? Persistence is also statistical. It captures recent weather trends to make short-term projections, assuming a degree of persistence is current at in the current atmospheric condition. So it utilizes simpler statistical methods like trend analysis and requiring minimal computational resources. So basically, this is a visualization of when they use this model for the data for their findings. So if we continue, how basically how does the entire ensemble work if we bring all the models together? So basically, there is individual model prediction. So these are three models used to come up with one model for the findings. So dynamical, climatology, and persistence. So every other model generates its own forecast. Then the weights combination. So each model receives a weight based on its historical performance, influencing its contribution to the final ensemble forecast. And then the final forecast. So the individual model predictions are combined based on their weights. So the one that has a bigger weight contributes more than one that has a smaller weight in the final forecast. So if you continue, then the training and evaluation. How do we train this model? So there is data acquisition, that is collecting the data, then data pre-processing. You keep processing the data again, cleaning again and over and again. Then the model training the model on the data collected. That is dynamical, that uses complex algorithms. Then climatology and persistence, which normally use linear regression and random forest to learn from the historical patterns. So the model evaluation, so each model is that like overall ensemble evaluated or unseen data to access the accuracy and skill in predicting the forecast. So basically, this is a study of how deployed models were performing with time. So basically, they look at the bias. So in the first week, we look at percentage bias, which was 37.3. Then after training the model on the data, it decreased to 6.9, and then the fifth week it decreased to 5.0. So they are trying to show you a trend, because this is temperature measurement against the different model types they employed. So they are trying to show you a dynamic change on how the model is behaving after some time of training, and how it reduces on the bias of towards this learning. So what do they use here? There was a tool, the quantile mapping. So with quantile mapping, it helps us to determine the quantile rank of the forecast value in the historical training data. So they replace the forecast value with the observed precipitation value that corresponds to the same rank. So this ensures that the distribution of the forecast closely resembles the distribution of the real world, leading to more accurate and reliable prediction. So this is a visualization of one of the findings. So we see that the ECMA, MWF, then with the biased, and then the ABC model, our ABC model that we are learning in the blue, and it has shown that it is being effective, and it's performing. Whenever it's tested, it is one of the best models that is giving the best results. So if we continue, then they use the Cote-Shapley value. The Cote-Shapley value, the methods used to access the contribution of individual explanatory variables to the overall accuracy of the forecast. So here, they just analyze values, and they identify the variables that can have the most significant impact on the forecast, and potentially define the system for even better results. So if we continue further, we can look at the calculating, how they calculate these values. So it's a combination of variables. Yes, they evaluate the worker skill and then the contribution of each variable independently, and then they keep on repeating the process to get the attained or the required value out of the process. So this is a visualization of what they did. From the first week, they retrain again, they reprocess until when they get a better output out of the model. So basically, that is it for this is the impact of the fifth of the this is a job potential height on the ABS skill improvement, on how it improves with time on how the ABS is performing. Then benefits of using this are the benefits of using the code sharply values, prioritize data collection efforts, then they refine the models within the ABS model ensemble, and they help develop targeted communication strategies to highlight the most relevant atmosphere factors for the stakeholders. So the model, okay, if the model got up and running, they looked at the applications of the system, such a system. So one, they had agriculture, then water resource management and disaster preparedness. Then, however, still they had the challenges while working around with the model, and some of the challenges were data volume and complexity, model complexity, then scalability and real-time application. So some of the future directions they have from their findings that there is incorporating additional data sources, then advanced machine learning techniques, yes, and then enhancing explainability. So basically, that is it from the paper, and the ABC ensemble model used to understand the bias towards sub-seasonal forecasts. So thank you so much. Again, my name is George Semaganda. Kindly subscribe to my YouTube channel. Feel free to post in case you have a question, and follow up for our project, machine learning project. That is the machine learning project. Uh, that is climatic. That is modeling for climatic geointelligence, modeling for climatic geointelligence to predict food security. And thank you so much. Uh, Enjoy.